Okay, we're going to talk about percent increase and percent decrease problems. And when you do these type of problems, there are two formulas to keep in mind. One is the percent increase, and what you do is you take the new value and you subtract the original value divided by the original value times 100. And the percent decrease is the reverse. It's the original value minus the new value divided by the original value times 100. So we're always going to be dividing by the original value, and we're always going to be timesing it by 100 to convert the decimal to a percent at the end. Okay? So let's look at an example. We have, after 1 year on his job, Grady got a raise from $16.50 per hour to $18.48 per hour. And the question is, what was the percent increase in his wage? So we need to establish two things here, the original value and the new value. If you look at the problem, the original value is what the original value is. Like what did they start with? And he started with $16.50 per hour. So that would have to be the so the original value is going to be $16.50. And the new value, which is his new wage, will be $18.48. So all we have to do is plug these values into the formula. So the original value would be $16.50 minus the new value, which is 18. Excuse me, one moment here. Let me go ahead and clean that up. Okay, so when we plug this information into the formula, when we do the percent increase, okay, we got to use the top formula, the new value minus the original value divided by the original value times 100. So the new value in this case is going to be $18.48 per hour minus the original value. His original wage was $16.50 per hour. We're always going to divide that by the original wage for both formulas, and we also need to times that decimal by 100 as well in both formulas. Okay, so that part of the formula never changes. So again, percent increase is new value minus the original value. Sometimes they refer to the original value as the old value. So when you see certain formulas, they may say new minus old divided by old minus new divided by old, right, for the percent increase. So just keep that in mind. I always like to say new and original value, but either terminology is fine. All right, so when you do the arithmetic here, when you take the difference here, you get 1.98. You divide that by 1650. Okay, and when you do that, you get 0.12, but again, you times it by 100 at the end, and you're going to get 12%. Okay, so always times the value by 100 to convert that decimal to a percent, because when you multiply something by 100, it's the same equivalency of moving the decimal 2 places to the right, which is what you have to do to go from decimal to percent. Okay, when we do a percent decrease, we use the percent decrease formula, which is original value minus the new value divided by the original value times 100. So a typical problem we see frequently when we go shopping in the grocery store, if a price drops from $150, or I'm sorry, any store, any item, I don't mean a grocery store, but just a store, when you buy something for $150, and let's say it drops to $75, well, we know logically that would be half, a decrease of half, so 50% a decrease. Okay, but if you wanted to use the formula, you would just say the original value minus the new value divided by the original value times 100. So we know the original value, or the original price, is 150. The new price that it dropped down to was 75. So what you do is you just take the original value, which is 150, you subtract the new value, which is 75. Again, you always divide by the original value, which is 150 in this case, and then times it by 100. And when you do 100 minus 150 minus 75, you get 75 over 150. And then when you do the arithmetic, you will get 0.5, and when you times that by 100, that'll give you the 50%. Okay? But regardless of what the numbers are, as long as you can identify the original value and the new value, you follow this simple arithmetic and you will get the percent decrease for that problem. Okay? The next topic that I'd like to review is simple interest. Okay, simple interest is basically how much interest you have to pay back on a particular loan after a period of time, usually measured in years. Okay, if it's anything under that, then it would be the months out of the total 12 months out of the year. Okay, but time is usually in years. Most loans are usually, for quite some time, so years is more common. But in any rate, the formula for simple interest is really easy to remember. It's I equals PRT. The I will always be the interest earned on this money borrowed. Principal is the original amount that you are borrowing. Okay, so if you buy a new car and it's $45,000, you go to the bank. Let's say you go to your credit union and you get approved. They cut you a check for $45,000. That would be the original amount that you would pay the car. Or if you're getting a loan, you're going to get interest. So unless you pay that car off at $45,000 with a check that day, you have to finance it, would be your other option. And then when you finance something, you have to pay the bank back interest, or they're not going to give you money for free. So you have to pay an interest rate for an X amount of time, and that's how they make their money. So in essence, that if you have a simple loan like $400 and you want to borrow that for 1 year at a 6% rate, then you would use the following formula. Okay, so the following formula would be I equals PRT. And the principal in this case, okay, is going to be 400. I didn't mean to write that. The principal in this case is going to be 400. The rate is going to be 6%, but when we use the formula, we got to convert that into a decimal, so that's going to be 0.06. Okay, you move the decimal 2 places to the left, add the 0, and it becomes 0.06. Okay, and then the time here is going to be in years, so it's going to be 1 year. Okay, so the formula is really easy. When you plug everything in, okay, you get I equals PRT, and you plug in the value 400, you multiply that by 0.06, and you times that by 1, and when you do the arithmetic, you will get 24. Okay, so that means that your interest rate will be $24. So you'll be paying back a total of $424 at 6% rate after 1 year. So this next example, if you borrow $2,040 at a 3% interest rate for a total of 6 months, we want to find the simple interest rate gained on this principal, or this money. So we use the same formula, I equals PRT. A principal is $2,040. The rate is 3.5%. Remember, that needs to be converted to a decimal, so you would need to make that 0.035. So you move the decimal 2 places to the left and add the 0, and then you'll have your decimal equivalent. All right, and the time now is 6 months out of 12. So that would be 6 out of 12, and when you reduce or do the division, you'll get 0.50 as the decimal equivalent, which makes sense because 6 months is half a year, right? So it'll be 0.5. You plug everything into the formula as we did in the previous example. Again, when you do 612 for time, you're going to convert that to a decimal. So go ahead and replace that with 0.50 instead. And then when you multiply the three quantities together, okay, you will get $35.70 of interest. That will be added to that $2,040. Okay? So it's a pretty simple method, pretty simple formula to use. Okay, in this next example, we're going to discuss future value. Basically, what are you going to be paying? What are you going to be paying? Basically, at the end of this loan after a certain amount of time. So if you read the problem, Tony opened a hot dog stand last April. He borrowed $6,300 and agreed to pay off this loan in 7 months at 8% interest rate. So he wants to borrow $6,300 to build this hot dog stand, or open up this hot dog stand. All right, so again, the principal is still going to be what we borrowed, the original amount borrowed, which is $6,300. The rate is going to be at 8%, but when you convert that to a decimal, it's going to be 0.08. And then, of course, the time is going to be 7 out of 12 months. Okay, so when you do, 7 divided by 12, okay, you will get the decimal equivalent of 0.58333. It kind of just repeats, okay? So that's going to be that, all right? So we're going to plug all the information into the formula, okay? Formula is the A, by the way, is the future amount. When you think about this, if you're borrowing money, you're going to pay back more than what you borrow because of interest, right? So if you're borrowing $6,300 at the end of this loan, okay, and at the end of 7 months, you'll be paying slightly higher, a little bit higher, because you have to add all the interest in the 7-month period of time. So when you use the formula, you just basically, A is what we're trying to solve. Okay, so we know P is going to be 6,300 plus 1 plus R. Well, the R is 0.08 times 0.5833 with the bar. Okay, so put that in all parentheses. So when we do the arithmetic, okay, the 0.08 times 0.583 needs to be multiplied. So we're going to take that value and we're going to multiply it by 0.08. Okay, and you add 1 to that. Okay, and you'll get 1.04666, and that kind of repeats. And then you take that and you times that by 6,300. Okay, so I am just I'm basically just confirming my calculation to be 6,594. Okay, so what you want to do is that when you plug in your values into the formula, go ahead and follow order of operations. 0.08 times 0.583. Remember that 3 is repeating, so when you convert 7 over 12, keep that whole decimal in the calculator and then times that by 0.08, and then you'll get 0.0466. Again, that also repeats. Add 1. Okay, when you add 1, you'll get 1.04666. And then you take that and you got to multiply it by the 6,300. And you get a total of $6,594 that you would have to pay back, or Tony would have to pay back after the 7-month period. Okay, I hope you found this video very helpful. I'll see you in the next video. Thank you for watching.